Have you ever been there? You're staring at your screen, wondering why on earth that button won't just sit next to that image, or why your fancy new drop-down menu keeps hiding behind everything else. Well, today we're going to map out the core CSS properties that control all of that, from how elements normally behave, all the way to stacking them in 3D.
All right, so in our last explainer, we covered the box model. And the big takeaway was that every single thing on a web page is basically a rectangular box. So you now know how to control the size of that box, the content inside, the padding, the border, and the margin around it.
But that leaves a pretty big question, right? Once we've shaped all our boxes, how do we actually tell them where to go? How do we make them sit side by side, or overlap each other, or maybe stick to the top of the screen when a user scrolls? That is exactly what we are going to map out today.
Here's our roadmap. First, we'll get a handle on the normal flow of a document using the display property. Then, we're going to learn how to break out of that flow with position. After that, we'll tackle how to stack and layer elements with z-index, and to wrap it all up, a super important checkpoint, the rule of specificity, which is basically how the browser decides which style wins when there's a disagreement.
Okay, first up, the normal flow. This is the default way your browser lays out everything on a page, and it's all controlled by one really fundamental property, display. Seriously, understanding this is the absolute key to mastering CSS layout.
So, what is this normal flow? Well, you can think of it as the browser's built-in set of rules for how to arrange things. By default, elements come in two main flavors, block and inline. Block elements, like paragraphs or divs, are kind of antisocial. They stack on top of each other, each one demanding its own line. Inline elements, like words in a sentence, are happy to just flow horizontally, one after the other.
Let's really break that down. Over on the left, we've got display block. Think of these guys as greedy. They always start on a brand new line and stretch out to take up the full available width, pushing everything else down. Then on the right, you have display inline. These are the polite ones. They only take up as much space as their content actually needs, and they'll happily sit next to other inline elements. But here's the catch. Width and height properties just don't work on them.
So what if you want something to sit next to other elements, but you also need to control its size, like a custom button? That is the perfect job for display inline block. It's really the best of both worlds. It lets elements flow horizontally like they're inline, but it also gives you the power to set a specific width and height, just like a block element. Fun fact, before modern tools like Flexbox and Grid came along, this was how developers had to build a lot of their column-based layouts.
Now, before we move on from display, let's clear up a super common point of confusion. What's the difference between display none and visibility hidden? Well, display none completely vaporizes the element from the page. It's like it was never even in the HTML. Everything else just shuffles up to fill that empty space. On the other hand, visibility hidden just makes the element invisible. It's still there, taking up its original space, but now you've just got an empty gap. So one removes, the other just hides. It's a critical difference.
Okay, so display sets the ground rules for how everything flows normally. But what happens when we need to break those rules? You know, for things like pop-up modals or navigation bars? That brings us to our next stop, breaking the flow, where we're going to use the position property to take complete manual control.
The position property has 5 main values you need to know. Static is just the default, nothing to see here, just normal flow. Relative is our first step into moving things, letting you nudge an element around. Then you have absolute and fixed, which are way more dramatic. They completely pull the element out of the normal flow. And finally, there's sticky, which is this really clever hybrid of the two.
Let's look a little closer at relative. This lets you use properties like top, bottom, left, and right to shift an element. But here's the really crucial part to remember. Even though the element looks like it's moved, the layout still holds its original spot open. It kind of leaves a ghost of itself behind, so nothing else moves in to fill that gap.
Now, position absolute. This is where we really start breaking the rules. It's like giving an element superpowers. It yanks it completely out of the document's normal flow. The space it used to take up just vanishes, and all the other content reflows to fill the void. Its new anchor point becomes its nearest ancestor that also has a position set on it. If it can't find one, it'll just be positioned relative to the whole page.
Now this slide shows the difference between fixed and sticky perfectly. An element with position fixed is basically glued to the viewport, the browser window you're looking at. When you scroll, it stays in the exact same spot. Think of a back to top button. Position sticky is a little smarter though. It acts like a normal element until you scroll to a certain point, and then it sticks to the screen,
But, and this is key, only inside its parent container.
And this is the most important thing to get about sticky positioning. As Elad Schechter puts it, a sticky element is basically trapped by its parent container. Yeah, it can stick to the top of the viewport as you scroll, but as soon as you scroll past its parent, that sticky element gets pushed up and away right along with it. It just can't escape its parent's boundaries.
So, we can place elements anywhere we want now, but what happens when they start to overlap? How do we decide which one appears on top? This brings us into a third dimension, the z-axis, which we control with z-index and a concept called a stacking context.
A stacking context is like its own little 3D universe for layering elements. Inside this context, you can stack things on top of or behind each other. But here is the golden rule, the one thing that trips up every single developer at first. Z-index does absolutely nothing on an element that has the default position static. You have to give it a position of relative, absolute, fixed, or sticky before z-index will have any effect at all.
Let's walk through a quick example. So, by default, if you have 3 positioned elements, they'll just stack based on their order in the HTML. The last one in the code appears on top. But look what happens when we give the very first element a higher z-index, like z-index 2. Boom! It immediately jumps to the front of the pile. It's that simple. The higher the number, the closer it is to you.
Now, let's talk about the common pitfalls, because z-index can be tricky. The biggest one is what I call the z-index trap. If a parent element has a z-index, it creates this private stacking world for its children. A child element, even with z-index 9999, can never appear on top of an element outside its parent, if that parent is stuck on a lower layer. This is the #1 reason why your modal's dark overlay sometimes gets stuck under the website's header. It's a classic.
All right, for our final leg of the journey, let's hit a quick bonus checkpoint. Now, this isn't strictly about layout, but it's absolutely crucial for understanding why your styles, including position and z-index, are or maybe aren't applying. We're talking about the rule of specificity.
So, when you have multiple CSS rules trying to style the same element, how does the browser decide which one to use? It uses a scoring system called Specificity. You can think of it like a game of top trumps. An inline style is the most powerful card. It beats everything. An ID selector is like a king. It'll easily beat a class, which is like a knight. And the knight, in turn, beats a simple element selector, which is like a pawn. The selector with the highest score wins the battle, and its style gets applied.
And that's really the bottom line. Specificity is the official rulebook for any CSS conflict. If you understand how it works, you can save yourself hours of frustration wondering why a style just won't apply, because you'll know exactly which rule is overriding another one and why.
So let's quickly recap our journey today. We started with display to understand and control the normal document flow. Then, we used position to completely break out of that flow and place elements exactly where we want them. We managed the overlapping layers with z-index, and finally, we learned how specificity helps us resolve any style conflicts that pop up. These are the absolute fundamentals of CSS layout.
Now, while these properties are foundational, for a lot of complex, modern layouts, you're probably going to reach for more powerful tools like Flexbox and Grid. But in our next explainer, we're going to build on this foundation and explore how to style more structured content like tables, lists, and images.
But before we go, I've got a question for you. What's the most creative or just plain surprising use of Position Sticky you've ever come across on a website? Drop your answers down in the comments. I'm genuinely curious to see what cool stuff you found. This is Developer Roadmaps. Map your path, build your career.